What we're going to talk about now is optimization techniques for game development and specifically for next-gen games. Next-gen games look really great, but if they don't play great in terms of performance and frame rate, then it's pretty much pointless as your game will not be fun at all, especially if you have something that's fast-paced like an action game, a third or first-person shooter. You're going to have some serious issues if your performance is not up to par, okay? So a game has to look good and it has to play good as well. In Unity, I'm going to show you here, from here on out, I'm going to show you some great optimization techniques you can use to squeeze out the most performance you can out of your game. So let me go over some of these optimization techniques that you can use. The first thing I want to talk about is per object shadow casting receiving, okay? By default, when you place objects inside of Unity, like FBX files that you import, meshes, things like that, they're automatically going to be set to cast and receive shadows, okay? This is good in the sense that you don't have to do it, it's automatically done for you, but it's bad in the sense that if you have 1,000 objects in your scene, all 1,000 objects are going to cast real-time shadows. This can be a serious problem because lots of times most objects are not important and don't need to waste computational power working with shadows and things like that. So what you want to do is you want to look at your scene, select specific objects, and you want to kind of ask yourself, okay, does this crate or this shelf or this little rock on the floor, is it important? Should it cast shadows in the scene? Should it not cast shadows? So things that are important, things like characters, maybe, I don't know, a vehicle in the game or something important should cast shadows, but something like a piece of debris on the floor, a little brick on the floor, something like that, you probably shouldn't waste any of your performance trying to cast shadows for stuff like that. Okay, so that's kind of the idea. The next thing is shader complexity. This is another big one. You have to be aware of your shader type. Okay, we have two different types of shaders here in Unity: a vertex lit shader and pixel lit shaders. Vertex lit shaders. What are the pros? The pros to vertex shaders are that they render really, really fast, so they're very performance friendly. The downside to vertex shaders is they're not complex at all. They're very simple. So you can't use complex things like normal maps. You can't use things like parallax normal mapping, parallax bump mapping. Really advanced things and really advanced lighting just won't work with vertex lit shaders. They're best used for things like mobile games or games that are going to be running on a platform that's very limited, not really for next-gen games. However, we could take advantage of them in the sense that if we have an object in our scene that is not really important or is really far away from the camera, we can try out using vertex shaders, and it can actually look pretty good while saving us some resources. Pixel shaders are great. The pros to pixel shaders are that you can achieve a next-gen game with them. They look great. You can use things like normal mapping, specular mapping, parallax bump mapping. You can use really cool effects, high-end lighting and shadows. They're the best in terms of quality, but they're not the best in terms of performance because they're more complex. They eat up more resources and are a little bit more difficult to render. The next thing is light linking. Light linking is pretty important. Unity gives you the ability to link specific objects to lights. This used to probably be the best performance tool for getting performance to work out really good for games in previous versions of Unity. However, now with Unity 3.0, light linking is kind of limited when you use deferred lighting. But on the upside, deferred lighting is great. It pretty much makes light linking obsolete, okay, just because of the way that deferred lighting works. So you don't have to worry about light linking too much. Now, polygon triangle count. I think I've mentioned this before in this tutorial, but there seems to be this misconception out there that the polygon triangle count is going to kill your game. Of course it could. If you bring in a model from, say, ZBrush, that's 3 million triangles, that's not going to work out too well for you. However, don't be afraid to push your character models and important assets to really high triangle counts. Most next-gen games, have characters that are easily 10,000 triangles, if not more. Okay, you look at games like Gears of War and other high-end games, the character count, triangle counts are really, really high. They really push it. Unity 3 can draw a lot of triangles on screen at one time. So polygon triangle count, don't be very afraid of that. You can push that pretty far. You'd be surprised how far Unity can go in terms of polygon and triangle count. Combining objects, this is very, very important. This can actually make a huge performance difference, and actually, if you don't know how to do this right, you can actually crash your game, okay? Combining objects, so what does that mean? Let's say, for example, you have a scene of a street, an outdoor area, a little city street, and you have lots of stop signs, okay? Say you got 20 stop signs in this area. If you have 20 different kind of independent stop signs, Unity has to load all of these objects, and it has to render all of these objects, and it considers them all to be separate objects. This takes a bigger toll on performance than if they were all one object. So since they're all the same object, the smart thing to do in this example would be to take all the stop signs and combine them into one stop sign, into one object. This would allow Unity to see it as one object, load it as one object, and render it as one object, which allows it to get better performance. Okay, so you want to combine objects as much as possible. You notice, for example, in the warehouse scene that I've created, all of the crates are considered to be one object. This was done on purpose to get better performance out of Unity. Sharing materials, this is also very, very important. The more indistinct or the more distinct and separate materials you have in your scene, the worse your performance is going to be. Okay, so for example, with the crates that you saw in my scene, you notice that I have a lot of crates, and they all use the same material, the same exact shaders used for all those crates. If I have 15 different crate materials, that's going to take a big toll on Unity and on performance. And then we have texture resolution. This is actually a big one, okay? We're all kind of inclined to use high-res textures because obviously games look a lot better when textures are high-res, especially when the player can walk up to a wall or a floor or another character and kind of admire the high-resolution texture work in that asset. However, be careful about this. Don't use high-res textures all over your scene. Don't create a scene where you have 2,000 objects and they're all using 2K textures. That would be insane. You start applying 2K and 4K textures all over your scene, you're going to have a serious problem. I would suggest just using something like a 2K or 4K texture on important things, like a character, for example. And if objects are far away, like on the ceiling or on rooftops or something where players not going to get close to, you might want to use lower resolution textures. Back in Unity here, I'm going to show you a couple of tools very quickly before I end this video that we can use for performance. Let me go to my layout. I'm going to switch back to a 2x3. Down here in the game view, okay, you can see it. We have this little stats button right here. What the stats button does, if we click on that, it's going to open up the statistics window. And I play this with the stats window on. You notice it's updating in real time. It's showing me information like the number of draw calls, you can see. It can also tell me how many tries and how many verts are being drawn on scene, how many used textures in terms of memory, render textures, screen resolution with the anti-aliasing, VRAM usage, and animation data, stuff like that. This is very important to optimize your game. You need to know what's going on under the hood at all times so that you can optimize your game as best as possible. This is a little bit of a science and an art at the same time, in the sense that you kind of have to have experience and kind of know what you're doing using this statistics window to determine which areas of your game may be slowing down the frame rate. The other tool that we can use, and this is a Unity Pro feature, is if we go up to the window menu, we'll find this option here called Profiler. If we open that up, this opens up the Profiler window. It's a little bit large at the moment. Let me reduce the size of that. The Profiler window gives you a breakdown of your scene, pretty much everything that's going on. It's a lot more detailed than the statistics window. This is more for professional usage. It's more advanced, but I'll show you how to use it. Basically, we're going to use this to kind of troubleshoot our scene, find out where our performance is good and where our performance is bad. I just want to show you those tools real quick. I'm going to end this video here. In the next video, we'll actually start to do actual optimization and get the scene to run good at the best frame rate possible.